In today's lesson, we're going to be solving systems by graphing. So what is a system of equations? Well, a system of equations is the solution to two or more equations. And then what is the solution to the system of equations? Well, the solution is an ordered pair where the lines intersect on the graph. All right, so how do I determine if an ordered pair is a solution? Remember, we're saying that the solution is going to be for two or more equations. And so we've got two equations here, and we're checking to see, is the solution or ordered pair 0, -4 a solution of this set of equations that we have below here? X plus y is equal to -4 and x minus 5 is y is equal to 20. So what we're going to do is we're going to take our ordered pair. Remember, the ordered pair is a set of an x and a y, and we're going to plug it in to see if it's actually a solution. So I'm going to take 0, which is x, plus -4, and is that equal to -4? Well, -4 is equal to -4, so yes, that is a solution. But it has to be the solution to both of these equations. So let's check the next one. I'm going to plug in 0 minus 5 times -4, and is that equal to 20? -5 times -4 is equal to 20, and so 20 is equal to 20, so yes, this is a solution to this system of equations. All right, so we have the ordered pair 3, 3. So let's plug in x, y. So is 3 plus 2 times 3 equal to 9. All right, 3 plus 6 equal to 9. Well, 3 plus 6 is equal to 9 is equal to 9, so that works. Now we've got to plug it into the next one because it has to work for both. So we're going to plug in 4 times 3 minus 3, is that equal to 15? Well, 12 minus 3 is not equal to 15, and so therefore, because it doesn't fit for both of those, it is not a solution to this system of equations. All right, so in this chapter, we're going to be learning 3 different methods of how to solve the systems. And today we're going to learn about how to solve systems by graphing. Remember that the solution is that ordered pair where the lines intersect, where they cross on the graph. So if we're going to be solving these by graphing, we need to graph both of these points to see then where they're going to intersect. So I'm going to graph my first one. I have y is equal to 1/4 x minus 2. So I'm going to graph this by starting at my -2, and then I have a slope of 1/4, so I'm going to go up 1 over 1, 2, 3, 4. All right, so I've graphed this one, and sometimes for these I like to graph and do more than one point because I'm looking to see where they're intersecting. And then so up 1, 1, 2, 3, 4, and then I'm going to go the opposite direction too in case it goes that direction. I'm going to go down 1 and then -4, 1, 2, 3, 4. All right, and if it doesn't fall on this straight line, sometimes I don't graph them very straight. Anyways, we've got the idea there. Okay, so now let's graph the other one. What I have is, I have 5. So my next one, my y-intercept is 5. And then my slope is up 2 over 1. Up 2 over 1. All right, so I'm going in that direction. Well, what I'm looking for then, since if I don't draw a really straight line, I like to then just back up down 2 over 1. All right, so now we can tell where these had crossed. So notice that it had crossed on this point right here. Let's do that in red. So we have negative 1, 2, 3, 4. So this point right here is negative 4, negative 3. And let's just go back up and let's plug this in here and to show. If I plug in this negative 4 and negative 3 over here, half or 1/4 of negative 4 is negative 1. Negative 1 minus 2, is that equal to negative 3? Yes. Let's plug it into this next one. Let's plug in the fourth. So negative 4 here and negative 3 over here. So if negative 3, is that equal to negative 8 plus 5? Yes, negative 8 plus 5 is equal to negative 3. So our solution then to this system is going to be negative 4, negative 3, the point at which they intersect, because this point is a solution to both of those equations. All right, number 2. I have x plus y is equal to 10 and x minus y is equal to 6. Well, this one, I think the easiest way for me to graph this one, I could certainly solve for y, but I think this one, I'm going to graph this using the intercepts. So I'm going to take my x plus y is equal to 10, and I just need the 2 points, and I'm going to plug in the 0 and the 0. All right, so when y is 0, x is 10, and then when x is 0, y is 10. All right, so now let's graph this. I have 10, 0, and I have 0, 10. All right, so let's connect our dots there. All right, so now we have to do it again with our equation x minus y is equal to 6. Plug in 0 and 0. So when when y is 0, x is then going to be 6. And then let's erase that. And then we're going to plug in here. Now remember, we have negative y is equal to 6. I've got to divide by a negative 1, and so I'll have negative 6. So I have the points 6, 0, and I have the point 0, negative 6. All right, so make sure you draw a nice straight line so you can really see which point is going to be the solution. And notice right here is where they're going to intersect. And so let's put that in red. All right, so we have over 1, 2, 3, 4, I believe that's 8, 2. All right, and so 8 plus 2, is that equal to 10? Yep. And is 8 minus 2 equal to 6? Yep. So we know that we've done this correctly, and our solution to this system is the coordinate 8, 2. All right, for this next one, we have y is equal to x minus 8 and y is equal to negative 2x plus 1. So this one, I think the easiest way to do this one is to do the slope and the y-intercept. So I have a y-intercept for the first one of negative 8, and then I have a slope of 1. So I'm going to go up 1 over 1. And I'm going to do it a few times just because sometimes I don't draw the straightest lines and then it makes it confusing. There we go. All right, and then I've got y is equal to negative 2x plus 1, so I'm going to start right here, and then I'm going to go down 2 over 1, down 2 over 1, down 2 over 1, and now I can clearly see where that's going to intersect, and it's right here at that point right there. Again, I don't draw the straightest lines, but you can see where it was supposed to go through that. And that is at 3, negative 1, 2, 3, 4, 5. So 3, negative 5. And so let's see here. Our solution is to the system is 3, negative 5. And again, you can plug it in just to double check it. I've got is 3 minus 8 equal to negative 5? Yep. And then you could plug it into the other one and you'd see that it is a solution to both of those equations. So our solution is 3, negative 5. All right, in our last one, we have 2x plus 4y is equal to 8 and 2x minus 2y is equal to negative 10. And since these are in standard form, and I can divide them evenly, I'm just going to, instead of solving for y, I'm going to use my x and y intercepts. So when I plug in 0 for y, I have 4. When I plug in 0 for x, I get 2. So I have 4, 0, and 0, 2. And our next one is 2x minus 2y is equal to negative 10, x and y. So when y is 0, I have negative 5, and when x is 0, I get positive 5, because negative 10 divided by negative 2 is positive 5. So I have negative 5, 0. All right, so let's plot these points. I have negative 5, 0. And then I have 0, 5. All right, now it looks like right here is our point of intersection. So what do we have? Negative 2, 3. And if you want to plug that in, I have negative 2 and 3. So it's negative 4 plus 12 equal to 8. Yep, and I can plug it into the other one. So the solution to this system right here is negative 2, positive 3. So in this lesson, we took a look at how to solve systems by graphing.